take notes on how to deal with division when you have factors with exponents in them. So you've already learned the rules that generally apply to multiplication, and so we're going to now talk about division. And so you take notes on these, which means copy down the problems in your notebook and write down exactly what I write down, stopping as you need to understand, rewinding as you need to understand, or you can also print a copy of this out. I will post the blank copy, and then you can take notes directly on that, take a photo of it, and turn it in. So, starting off, here's the general rule. If you remember back in your earlier days of math, quotient is another word for division. So here we have a quotient of powers. So what do we do when we divide by exponents? Well, if you have the same base, you have the rule here that says a number to a power m divided by a number to a power n. You subtract the exponent. So I'm going to use number 1 to show you why this rule works the way it does. Because if you recall, when you had multiplication, if you had a to the m times a to the n, you add those. And you've been using that rule. So the division, you're going to subtract exponents. So here's why that's true. So number 1, we have 2 to the 5th. We could write this out in expanded form as 2 times 2 times 2 times 2 times 2. And on the denominator, we have 2 times 2. Well, what you should remember from earlier days of math is that if you have a factor on the top and a factor on the bottom, you can effectively cancel. So this 2 and that 2 will cancel out, and this 2 and that 2 will cancel out. And so what you're left with is 1 on the bottom, and then you have 3 2's left on the top. So this would really be 2 to the 3rd power. Well, what happened when we canceled those things out is we had 5 2's on the top, we had 2 2's on the bottom. If 2 of those 2's cancel out with the 5 on the top, we're basically taking away or subtracting. So that's why the rule of subtracting works. And if you know that rule, then you don't have to write all this out in expanded form. So, moving on to number 2. X to the 4th over x to the 3rd. We have 4x's on the top and 3x's on the bottom. So really we're taking away the 3 on the bottom from the 4 on the top. And so we're going to show... Excuse me. You get to listen to me sneeze too. Awesome. Okay, x to the 4 minus 3 power, because that's our rule. 4 minus 3 is 1, so we get x to the 1, or that's just x. All right, number 3, you notice the exponent on the numerator on the top is smaller than the numerator, or the exponent on the denominator on the bottom. But that's okay, we're going to use our rule exactly the same. So we have m to the 5th over m to the 8th, and so we get m to the 5 minus 8. So that equals m to the negative 3, which is correct, except what you've been learning is that you don't want to leave your answer with a negative exponent in it. So we have to use our final rule of what does a negative exponent mean. Well, it means flip it upside down, so if it's over 1, we're going to make this become 1 over m, and this becomes positive 3. I'm just going to show you up at the top why that's true. Is here we had 5 m's, and on the bottom we have 8. And if you were to cancel all 5 on the top and 5 of those on the bottom, you're going to be left with 3 on the bottom, and that's where you'll see how that works. Okay, number 4. When you have multiple different bases, so for example, number 4, we have a base of D and a base of E, you're just going to kind of treat those as separate problems, and then we'll put it all back together. But the first thing we have to deal with is these parentheses. And you have a power outside the parentheses, so if you remember, that exponent gets hand it out to everything on the inside. So I'm going to show what that looks like. So d to the fourth, d to the third. And then on the bottom we have d squared e squared because this 2 went to each thing on the inside. Okay, so now we can deal with the d's and we can deal with the e's independently. So d to the fourth over d to the squared is d to the 4 minus 2 because we're dividing those. And e to the third over e squared is e to the 3 minus 2. Well, d to the 4 minus 2 is d squared. E to the 3 minus 2 is e to the first, or just e. Okay, number 5. Now we have 3 bases, so we're going to treat them as 3 independent problems. So we have 3 sitting alone there, and we need an exponent. We can give it an exponent of 1, because that doesn't change the value. So we have 3 to the 1 minus 2 times 4 to the 3 minus 4 times 5 to the 5 minus 3. Well, 3 to the 1 minus 2, that's 3 to the negative 1. We'll deal with that in a second. That's 4 to the negative 1 and 5 to the second. So those 2 bases with a negative exponent need to move to the denominator to become happy with positive exponents. So I'm going to draw my fraction bar. The 5 to the second is happy where it is, so we're going to keep that up top. And then the 3 to the negative 1 goes to the bottom and becomes 3 to the positive 1, which we can just write as 3. And the 4 to the negative 1 comes to the bottom and becomes 4. And technically, so we could multiply all this out, and 5 squared is 25. Three times 4 is 12. So that could be the answer. Number 6. Okay, so we have 3 different kinds of bases. We have numbers, there's no exponents there, but there's a division problem that we can do. Then we have a base of e and a base of f. So 15 and the 5 can cancel to leave a 3 and a 1. So we have 3. E, dividing, we can subtract exponents, so that'll be 5 minus 7. F to the 8 minus 5. So 3e to the negative 2, f to the third. The 3 and the f to the third can stay on top. And e to the negative 2 goes to the bottom. Okay, number 7. Don't get worried at all about negatives. You know how to do the negative addition and subtraction. So here we just have a quotient, so we're going to need to subtract exponents. So we have x to the negative 3 minus 6. Well, negative 3 minus 6 is the same as negative 3 plus negative 6, or negative 9. So this is x to the negative 9. And the last step is to flip it upside down to make the exponent positive. So you should end up with 1 over x to the 9th power. And we'll put that all together on number 8. So we have 2 different bases, m's and n's, so we'll deal with them separately. M to the 2 minus negative 4 times n to the 1 minus negative 3. Well, 2 minus negative 4 is the same as 2 plus a positive 4, which is to the 6th power. 1 minus negative 3 is the same as 1 plus a positive 3, which is to the 4th power. And that is all we can do. All exponents are now positive. We're happy. And that's it. Hope this made sense. Again, make sure you went through it carefully, and